Hi, my name is Mikkel Thyssen, and I'm the product manager for Vibration Diagnostics Development Value Stream. And today I'm here to tell you about our service that we call Vibration Diagnostics Data Access. And that is basically applicable for all of the customers that has an Vibration Diagnostics subscription. So for all of the data that we gather from the wind farms that is owned by you, our customer, you can also get access to the same set of data that we collect from your turbines by the means of an API. And the way that you can get access is basically by following these four simple steps. So we will provide the credentials that you need, that you use to query Microsoft Azure, and in return you get a valid token. Now this token you have to use for every API call that you make, and if the API call is valid, and then you get back the data. So it's in principle relatively simple. Let me show you how it looks like in reality. So I should say that API is an application programming interface. So it's a programming interface for an application. It's not a user interface for visualizing the data. However, on the front end of the API itself, there is this Swagger implementation that provides some information about how the API functions. So here we are on the API. And you will see the information that you need in order to retrieve the authentication token. Now you get that by making a post request to the Microsoft login service, and you get the tenant ID, you get the client ID, and you also get the client secret from SGRE. And with this information, you can make the post request and then get back a valid token. So I will just do that, and then I get the token. So I'm using Postman for making the post request, but you can also use another application, of course. So now I've authorized. So then the connection between the endpoints is like this, yeah. So you have the starting points being the turbine's endpoint. You can use this endpoint to execute without any parameters, and then you get back a list of all of the turbines that you have access to. So here I will select one random turbine from the list that I have access to from this demo account. And then the next endpoint is the turbine metadata endpoint. Here I have to provide the turbine ID, and I should say that this turbine ID is not the turbine ID that you are used to from within your turbines. Yeah, it's a non-information bearing ID. When I execute this endpoint, I get all of the data that exist on this turbine, right? So for every sensor, vibration sensor in the turbine, there is an ID, and there is also a sensor name. So here we have for this sensor ID 229, that is the gear HS, which is the high-speed gear. And then you have all of the measurements that is acquired from this sensor. So, for instance, here's the Kepstrom 1000P2 tracked, and that has a measurement ID of 1. And the first measurement that has ever been recorded from this turbine on this measurement ID and sensor ID was in year 2023, and measurement month number 3, meaning March. Yeah. So there is no data prior to this point in time. Now, with this information, I can go to either the measurement endpoint or the measurement metadata endpoint. So if we just quickly go to the measurement metadata endpoint to begin with, then you can see here the method has changed. Prior, it was a GET request. Now we use a POST request. So I put in the request here in the format of a JSON. And the turbine ID is the same as I used before. Now I need to provide a sensor ID. So now I'm just picking the first one that we had there. And a measurement ID. Let's take the first one. So that was measurement ID 1, was year 2023, and the month was 3. So when I then execute this, I get a response back here. That's telling me that this was created in March 2023. There's a timestamp as well. And then it's giving me some information about the content length, right? So the size of the file and when it was last modified. This is useful if you want to set up a synchronization job to keep your own database updated with data that we are also collecting from your turbines. Then you can run an update script every week or with the frequency that matches your needs. And then you can compare the files that you collected during the last synchronization with the version of the file that we have in terms of either the file size, or just synchronize all of the files that we have updated since your last synchronization job ran. If you would then like to collect the file from our API, you use the other endpoint, which is the measurement endpoint, but you send the exact same JSON through the POST request. So it's pointing to the exact same file. When I then execute this one, I get the file, yeah, right? So you can also see what is then the curl request for this specific file. So here you have the JSON, right? So the Swagger implementation here is basically just to provide you with some documentation of how this API works. Obviously, you then implement the API into your own application, either a front-end application or a synchronization job for keeping data updated in your own database. Once you then have the file, then you can, it's just called data paquet file. Yeah. So I'll just open it up here for you to see. So I'm just using this paquet viewer right now. But obviously you can read this data into a data frame in, for instance, Python or something like that. Yeah. So you can see the content here. We have the metadata and we have the measurement data, and you can see that this is encrypted. Yeah, it's packaged. So the information about this file is kept here. Yeah, so the metadata is XML, but it's packaged like this. Okay, and the measurement data is single precision floats, and they are packed as hex bytes. So this is the information that is needed for you to unpack the data, and then you can start using the data subsequently if you want to. Okay, so this is a quick demo of the Vibration Diagnostics data access service. I hope you found that useful.